Gangnam Style. Gangnam Style.
Welcome back. Today we're talking about evaluating function notation, day 2. Let's take a look at some reminders. So a couple of reminders here. F of x means that this is a function. F of x represents the y value in an ordered pair, x and y. So for example, f of 2 equals 8 means 2, 8. F of negative 3 equals 4 means negative 3, 4. And the most important part of the way to remember that is that if it's inside the parentheses, it's the input. And if it's outside the parentheses, it's the output. We also use g of x, and h of x in order to represent multiple functions. Here we are looking at some function vocabulary to review. So remember, domain is the set of all the x values in a function. The range is all the set of y values in that function. The y-intercept is the point where the function crosses the y-axis. The x-coordinate is always 0. So 0, whatever your y-coordinate is your y-intercept. The x-intercept is also known as the 0, or the root of the function. The point where the function crosses the x-axis, so the y-coordinate will always be 0. So x, whatever your x-point is, and then 0 for your ordered pairs. Now let's take a look at some examples. So here we are at example A, where we've got a table and we've got some questions to answer. So the first one says find g of 6. So since that is the inside the parentheses there, we know that's the input. So we're looking for when 6 is the input. And if we're looking at our table, we can see that 6 is our input right here. So what is our output in that case? It appears to be lining up with the 5. So g of 6 is going to be 5. So 5 is going to be our answer there. And we can label that g of x, because we know that's our output, is equal to 5. Number 2 says find x when g of x is equal to negative 1. So we see that negative 1 there is outside our parentheses, so that is our output. So looking at our table here, we can see that negative 1 is going to be there. So our x-coordinate, or our input that's going to be matching up with that, is going to be 0. So if we were going to write that, it would be g inside the parentheses as 0, because that is our input. Or we could write this as an ordered pair now with 0, negative 1. Now we've got find x when g of x is equal to negative 4. So again, negative 4 is outside the parentheses, so that's an output. We can see negative 4 is right here, so our input is going to be negative 3. So we can write that as g inside the parentheses is going to be negative 3. Or as our ordered pair, we now have negative 3, negative 4. The last questions there talk about what is the domain and the range. Remember, the domain is a list of all of the x values, so we're going to write those in braces. We're also going to write them in order from least to greatest. So our domain here, we've got negative 3, 0, 3, 6, and 9. And our range is going to be the set of all the y values, again, written in order from least to greatest. We only include each each number one time. And again, we'll write them in order from least to greatest. So we've got negative 4, negative 1, 2, 5, and 8. Now let's take a look at the next example. Here we are at example B, and we've got several questions to answer there about our graph. So the first one says find h of 1. So we can see that 1 is inside the parentheses, so that's going to be our input. So we're going to be looking for when this parabola here is crossing, or is x is 1. So if I got x is 1 is here, I'm going to go up until I can see the very top of my graph is at 3. So my h of 1 is going to be 3. So we can say h of x is equal to 3. All right, then it says find h of 0. So h of 0, again, 0 is going to be the input in our graph. So again, we're going to find 0 up from our x. We're going to go up until we hit our point here, and that's going to be 2. So we've got h of x in this case is going to be equaling to 2. All right, then we've got to find x when h of x is equal to 2. So this one's a little trickier because we have to figure out 2 is the output. So that's going to be where our y is going to be 2. So the first thing I'm going to do is draw a line across the y value of 2 here. So we've got our y value at 2 all the way across. So we want to figure out where that line is going to cross our parabola. So we've got that crossing at 2 different locations in this particular problem. So we can see that that's crossing at 0, 2, and at 2, positive 2. So in this case, we've got 2 values that are going to satisfy that. So we're going to write those 2 values in our function notation. So we know that they are the x values now. So we know that that is going to be h of 0 in this case, and we're going to have h of 2 in this case. So we've got 2 of those. All right, our next one says that we've got to find when h of x is equal to negative 1. So again, we're looking for our y value of negative 1. So we're going to come across here on our y value of negative 1. And again, we can see that that's going to cross our parabola at 2 different places. So one of those points is here, and the other one of those points is here. So we've got negative 1, and 3, negative 1. So again, we're going to write that in our function notation. So we've got h of negative 1, and we've got h of 3. because again, these are inputs that we found, so they're going to go inside the parentheses. The last question is, what is our domain? Now, this is a parabola, so the parabola is going to be going on forever and ever, and it's going to be getting wider and wider at the bottom. So it's going to eventually encompass all of the numbers along that x value, so it continues to go out further and further. So the domain in this case is all real numbers. All real numbers are going to satisfy this domain because eventually, as the parabola continues to expand, it's going to cover all of those numbers on the number line. What is the range, however, because this is a parabola that stops at 3, so it's not going any higher than 3. So all the values less than 3 will eventually be hit because, again, the parabola is going to expand and expand, but it's not going to go any higher than 3. So all of our range here is going to be less than 3, so we're going to write that as an inequality. X is less than 3. Could it be 3 in this particular case? There is a point at 3, so it could be less than or equal to, in this case, 3, but it's going to cover all of those values. Now let's take a look at the last example. So here we are at example C, and it says find x and y intercepts of the function f of x is equal to 1/2 x minus 7. Write your answers in functional notation and as an ordered pair. So as we talked about, when you're talking about intercepts, you're going to be finding when each of the values is 0. So we've got to figure out our y-intercept and our x-intercept. Whenever we do our y-intercept, that's where our x value is going to be 0. So we're going to be substituting in 0 here. So we've got f of x, and we're going to be trying to figure that out for 1/2 x times 0 is going to be negative 7. So we're going to now simplify using the order of operations. So we got 1/2 times 0 is going to be 0. And then 0 minus 7 is going to be negative 7. So our f of x for that is going to be negative 7. So what's our y-intercept in this case? We're going to write that in function notation. So when we have f of 0, we know that equals negative 7. So we're going to write that now as an ordered pair. So our ordered pair of when x is 0, our y is negative 7. Now we're going to do the similar method to find what are going to be our x-intercept, or the 0 of the function. So this time we're going to be making y our 0, f of x. So we've got 0 is equal to 1/2 x minus 7. Now we've got a regular two-step equation to solve. So we're going to go ahead and draw our wall down from each side. We'll add 7 to both sides. These are going to cancel, leaving 7 equals 1/2 x. And my last step is going to be that I'm going to multiply both sides by 1/2, but multiply both sides by 2/1, which is the reciprocal. 2/1, 2/1, they're all going to cancel for x. And then 2 times 7 is going to be positive 14. So now that we have our x-intercept, we're going to write that in functional notation and as an ordered pair. So we've got to have our f of there. So our f of, and in this case, it's going to be 14 because that's going to be our x-intercept. And then we know when that is equal to 0, that is going to be f is equal to 14. So our ordered pair for this particular case is we've got 14 for our x value, and we've got 0 for our y value. So there is our ordered pair. That brings us to the end of this question. Also brings us to the end of this set of notes and this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.